Hello, dear friends. Many people are interested in how to lose excess weight and fix the result forever. I will tell you how fat-burning mechanisms work and how to fight excess weight correctly. Did you know that we can all differ from each other in terms of fat-burning rate by about 9 times? Some people can burn as little as 0.17 grams of fat in 1 minute, while others can burn 1.27 grams. And some of the most trained burn more than 1.5 grams of fat per minute. That's the kind of colossal difference that can amount to 8.823 times. To burn fat faster, we need to know what factors affect it, and accordingly, we can create such conditions so that the body burns fat faster. Considering the difference between people, it becomes clear that some people lose weight very quickly with seemingly little effort, while others do not manage to do it even with maximum effort. So, why do we waste fat? Our body can get its energy from 2 primary sources to supply the body with energy during physical work. These are the glycogen stores in the muscles and the liver. Glycogen is a polymer of glucose. Glucose is the fastest, high-octane fuel for our muscles. Many people think that the entire glycogen reserve must first be used to ensure the consumption of fat, which is less favored by the musculature, and only then will the body start burning fat. Fat takes longer to undergo a series of transformations to become available as fuel. It turns out that the maximum fat-burning rate occurs during low-intensity exercise, when the glycogen reserve is not even touched yet. Evidence suggests that the maximum fat-burning rate occurs when approximately 47 to 70% of maximum oxygen consumption is expended. Maximum oxygen consumption is a value that is very useful for measuring the intensity of physical activity. Each person's maximum oxygen uptake is different. Technically, it simply indicates your endurance. How fast can you run 1 or 10 kilometers? The faster you run, the higher your maximum oxygen consumption. A person reaches maximum oxygen consumption when he runs at the highest possible speed, skis, swims, or cycles. That is, performs any work that involves oxygen utilization. It is not lifting weights or strength exercises because during strength work, other muscle fibers are engaged, using pure glucose through glycolysis. This process involves the breakdown of glucose in the absence of oxygen. In other words, muscles do not practically need oxygen during strength work. But if you run, walk, or do other slow cyclic work, oxygen is, of course, needed. Energy is mainly produced by oxidizing various substrates in the presence of oxygen. When 47 to 75% of the maximum oxygen consumption is observed, it is the most active fat burning. At rest or with minimal physical activity, the energy supply in the body is mainly due to fat burning. As physical activity increases, the percentage of fat utilization decreases. At rest, glucose and carbohydrates are hardly spent at all. Glucose starts to be expended intensively from about 40% of the maximum possible load. Further, from about 65%, the share of fats in providing work falls progressively, and the proportion of carbohydrates increases. Maximum fat oxidation occurs between 45 and 65%. In some people, maximal fat oxidation can occur at 30% of maximum oxygen intake in untrained people, and it happens even at 87% of maximum oxygen intake in trained people. The more intense the workload, the less it is accomplished by fat oxidation. Consequently, the less intensive the workload, the greater the percentage of fat contribution to energy requirements. Thus, it is clear that to maximize fat intake, we need to be somewhere in the 65% range. It turns out that it is a myth that for the body to spend fat, it must first expend carbohydrate stores. Actually, it is quite the opposite. That is, fats are consumed first, and only then, when we reach a certain intensity of physical activity, our muscle cells switch to carbohydrate consumption. It is exciting how this switching mechanism occurs. You may know that there is a substance in our cells called carnitine. Carnitine is needed to transport fatty acids. The fatty acid combines with carnitine. Then carnitine has to be transported across the outer and inner membrane of the mitochondria to be oxidized. Then energy is made from fatty acids. 2 limiting enzymes are responsible for transporting the fatty acid within the cell. These are carnitine palmitoyltransferase 1 and carnitine palmitoyltransferase 2. Carnitine palmitoyltransferase 1 performs fatty acid attachment to carnitine and subsequently it is transported deep into the mitochondria. Then carnitine palmitoyltransferase 2 releases the fatty acid and releases carnitine. Carnitine then goes back to the outer surface, the outer membrane. So carnitine is shuttled back and forth like a shuttle bus. It happens until the cell develops enough pyruvate. Pyruvate is the end product of glycolysis. Glycolysis is the breakdown of glucose without the presence of oxygen. When the amount of pyruvate increases during intense muscle work, it reaches a certain amount. The enzyme pyruvate dehydrogenase makes acetyl coenzyme from pyruvate. This acetyl coenzyme combines with carnitine, which has already been previously transported inside the mitochondria. Carnitine plus acetyl coenzyme form a substance called acetylcarnitine. This acetylcarnitine cannot enter the outer membrane. Consequently, if acetylcarnitine cannot be transferred, there will be no carnitine on the surface of the mitochondrion. Hence, carnitine cannot combine with the fatty acid, and the enzymes carnitine polymethyltransferase 1 and carnitine palmitoyltransferase 2 are no longer involved. It is how fat oxidation is regulated. That is, as soon as our cells switch to intensive work, to glycolysis, when there is not enough oxygen, when shortness of breath begins, pyruvate accumulates, which then turns to acetylcarnitine and blocks the formation of carnitine on the surface of mitochondria. Accordingly, the fat will no longer be burned. So for optimal fat burning, you need to not cross the line, for some 50% of maximum oxygen intake, for some 65%, and so on. The technical question arises, how do you determine this maximum oxygen intake? Unless you're an athlete, you don't need to. Since you have already learned that oxygen availability limits whether you'll have fat oxidation or not, you need to keep your exercise so that you don't have shortness of breath. So if you can speak individual phrases to say single phrases with some exertion, that's the most appropriate regimen. When you can work for hours without exceeding this intensity, you will start to maximize fat burning. To increase the fat burning rate, you must make that fat more available. The most exciting thing is that our muscles, within the first hour and a half of work, use as a source of fat, not subcutaneous tissue, not subcutaneous fat, but the fat stored already in the muscles in the form of triglycerides. It is stored in slow muscle fibers. The more trained a person is, the more triglycerides are stored in the muscles. Triglycerides are located next to mitochondria, and consequently they are activated very quickly. And they are activated by catecholamines, which are norepinephrine and adrenaline. At the beginning of exercise, you have an increased release of adrenaline, noradrenaline, cortisol, and somatropic hormone. These are all so-called hormones that activate lipolysis, which is the breakdown of fat. There is such a protocol for advanced people who are well trained. At the beginning of a workout, do several series of intense work on the edge of an anaerobic threshold with shortness of breath. Several such intervals should be done to activate the release of adrenaline and noradrenaline well, so that it will activate the breakdown and mobilizes the triglyceride fats in the muscles. It turns out that the fuel is prepared. Then you go to a very low-intensity load. The fuel is ready and the fat starts to be burned. If you are unfit, like most people after 50 probably are, you don't need to do intense intervals at the beginning. Just start walking, running, or swimming, whichever you prefer. There is no time limit here. As soon as you make some movement, you have immediate fat oxidation. Don't be told that you must do some work for half an hour first when you will have your fats mobilized. That is absolutely not the case. Fats start to be burned immediately. Some people will ask, if the switch from burning fat to burning carbohydrates is because the concentration of carnitine on the surface of mitochondria drops, then cannot we add carnitine so that it binds to fats again, carrying them inside the mitochondria for further utilization? True, many people take carnitine supposedly to increase the rate of fat burning, but studies have shown there is no increase in physical processes or performance even if you saturate your body with carnitine. Carnitine does not increase energy production. So why is that? Perhaps the carnitine you drink during intense exercise accumulates in the working cell. But that carnitine is still insufficient for the fatty acids to be transported deep into the mitochondria. So what can we do to increase the rate of fat oxidation? Exercise for long periods at capacities that ensure the rate of fat oxidation, that is, at 45 to 65% of maximum oxygen consumption. In other words, at a level of exertion at which you can breathe and talk freely, and you can do this, of course, for a very long time, because these types of exercise are absolutely safe. You can also affect your body's ability to oxidize fat with your diet. The fewer carbohydrates in your diet, the more your body will be adapted to burning fat. It is just how people on a keto or low-carbohydrate diet burn more than 1.5 grams of fat in 1 minute, and those people who are on a high-carbohydrate diet burn only 0.17 grams of fat per minute. But to achieve such high rates of more than 1 gram per minute, you must train for a very long time, because here we're talking about the workout of enzymes in the mitochondria, which are responsible for burning fat. Studies show that progress can be seen over a year, 2, or even 3 years. Achieving maximum fat-burning efficiency takes a long time, but it is possible. It's worth emphasizing that I'm not a proponent of long-term keto diet because a lot is still unresearched, too raw. Simply limiting fast available carbohydrates in a balanced Mediterranean diet is enough. That's all a healthy person needs. Let's summarize. It is not at all necessary to spend carbohydrates first when exercising. At any low-intensity exercise, fat starts to be spent first, and the burning of carbohydrates occurs only after we move to shortness of breath and more intense physical activity. It is impossible to accelerate fat burning during intensive physical activity by taking carnitine preparations. You can train your fat-burning rate through prolonged exercise at a low heart rate without shortness of breath and by limiting rapidly available carbohydrates. Always there for you, Dr. PopMed.